Worksheet 2.2b, titled Rates of Change, talks about average rate and instantaneous rate. So when you look at average rate, you look at f of b minus f of a over b minus a, and that should look familiar. It should look familiar from your previous math classes because it's pretty much just a slope formula. Now, when you look at instantaneous rate of change, or an instantaneous rate, this should now look familiar because we've been looking at these types of limits, and it's pretty much the derivative. So the difference between the two is that when you calculate an average rate, you can use the slope formula, and when you are calculating an instantaneous rate, you need to use the derivative. So keep that in mind as you work out problems 1 through 4, because it's asking you to first find the average rate, and then of the given function, and then find the instantaneous rate. And we are considering the endpoints, 1, 4. So a is 1, b is 4, and the function for problem number 1 is f of x equals 2x squared minus 1. So for 1a, the average rate of change, we can use the slope formula. And the function, remember, is 2x squared minus 1, where a is equal to 1 and b is equal to 4. So we're going to go ahead and apply that to the slope formula. So we have f of 4 minus f of 1 over 4 minus 1. And we plug in 4 for every x value in our function. So it's 2 times 4 squared minus 1. So we have 4 squared, which is 16, times 2, which is 32, minus 1, so we have 31. And then we do the same thing with f of 1. We plug that in, plug 1 in for every x value. And when we calculate that, we get 1. So we have 31 minus 1 over 4 minus 1, which will be 31 minus 1 over 3, or 30 over 3, or 10. And that would be your answer for this problem. Don't forget to highlight your answer. Now for part B, the instantaneous rate, we're gonna have to find the derivative, but don't forget that you can use your basic derivative rules now. So unless it's otherwise stated, you can always use your basic derivative rules to calculate the derivative from now on. So calculating the derivative for 2x squared minus 1 isn't too hard. By using the power rule, you get that f prime of x equals 4x, and now we're going to calculate it on the endpoints. So that was 1 and 4. So the interval is 1 and 4. So f prime of 1 is just 4 times 1, which is 4. And f prime of 4 is just 4 times 4, which is 16. So the 1, a 1, the 4, a 4. Don't forget to highlight your answers. And that is how you do problem number 1. Alright, now I want to jump down to the next box in this worksheet. And we're talking about this position function f of t. And then there's a recap on displacement, where displacement is the change in s, or delta s. But what I really want to get into is the average velocity. I want you to compare average velocity just like compare it to average rate. So if you notice that the average velocity is just the slope delta S over delta T, and or the change of S over the change of T, and it's an average just like the average rate. We can use the slope formula. Now when you look at instantaneous velocity, I want you to compare that to instantaneous rate, where it's pretty much a derivative. And if you notice, instantaneous velocity is the derivative of the position function with respect to time. So when you see instantaneous velocity, think of the derivative. And then finally it talks about speed, and speed is the absolute value of velocity. So if we look at problem number 5, we can now apply some of these new concepts. And I'm not going to spend time reading it, you guys can read it, but it's pretty much giving us a function. We're asked to find the average velocity on the given interval. So we can use the slope formula because it's asking for the average. Okay, so we have f of t equals negative 16t squared plus 15, well, not 15, 512. And we want to use the slope formula. We have to first calculate f of 2 and f of 0. So f of 2, negative 16 times 2 squared plus 512, which will give us 448. And now we calculate f of 0. And f of 0 is pretty easy to calculate given this function, because we're going to plug in 0 here, and negative 16 times 0 squared will be gone, and we're just left with 512 as our answer. So our setup is 448 minus 512 over 2 minus 0, which is negative 64 over 2, which is negative 32. Now, what are the units? Remember, this is a rate. It's an average rate, but it is a rate. And remember that time was in seconds. And our function, negative 16t squared plus 512, was in feet. So these outputs are feet. So we have feet in the numerator, seconds in the denominator. This is negative 32 feet per second. Highlight the answer, and we're done. Well, with part A at least. Now part B wants the instantaneous velocity at t equals 2. So if you're thinking the derivative at t equals 2, you are thinking along the correct lines. So again, let's use f of t equals negative 16t squared plus 512. And again, you can use your basic derivative rules to easily calculate the derivative. And you should get negative 32t. Now, when t equals 2, we're looking for f prime of 2, and this will give us negative 64, because it's negative 32 times 2, which gives us negative 64, and the units are, again, it's a rate, it's feet per second, just like the average rate. Now this is the instantaneous rate. Highlight your answer, and we are done with 5B. Now for part C, how long does it take for the sandbag to hit the ground? You don't need calculus for part C. Think about it. What's the height if the sandbag hit the ground? How many feet off the ground is the sandbag if it hit the ground? Well, hopefully you're thinking it's 0. So we're looking for when f of t is equal to 0, and f of t is negative 16t squared plus 512. So that's negative 16t squared plus 512 equals 0. And if you can solve for t, you've found your answer. So basic algebra skills. We can subtract 512 from both sides to get negative 16t squared equals negative 512. Then we can divide both sides by negative 16. And we'll get t squared is equal to positive 32. And then we can take the square root of both sides. Now the square root of 32 can be simplified. That's 16 times 2, which is 4 radical 2. But regardless whether you simplify or not, that is approximately 5.657 seconds. Highlight your answer, and we're done with part C. And now D, with what velocity does the sandbag strike the ground? So we can actually make use of some previously calculated answers to answer part D. Now think about that. With what velocity does the sandbag strike the ground? So our function f of t equals negative 16t squared plus 512 is not what we want to directly use, because this is a position function. We don't want position, we want velocity. But we can make use of this position function because we now know that the velocity is the derivative of the position function. So what we pretty much have is that velocity is equal to negative 32t. So if this represents velocity and we want to know at what velocity the sandbag hits the ground, we know that the sandbag hits the ground at a certain time. We already calculated that, and that was 4 radical 2, which was approximately 5.657. I'm going to use t equals 4 radical 2. I don't want to use a rounded figure. I'd rather use the exact value of 4 radical 2 for time. So the velocity at 4 radical 2, because the sandbag hit the bag at 4 radical 2, is negative 32 times 4 radical 2. And you can calculate this to be negative 128 radical 2, which is approximately negative 181.019 feet per second. Now notice that the answer came out to be negative. Try to make sense of that. Why did it come out to be negative? And it came out to be negative. It makes sense because the object is going down, the object is falling down and it's going in the negative direction. So the answer being negative makes sense. I'll go ahead and stop the video here. I hope this helps.